name is Tobin Northfield. I'm an assistant professor of entomology at Washington State University in Wenatchee.
I'm Adrian Marshall. I am a postdoc in Dr. Northfield's lab, also in Wenatchee.
We're working on little cherry disease, which is probably the biggest impacting problem with cherries. Washington is the biggest producer of cherries, sweet cherries in particular, nationwide, and this is a major problem that causes little cherries on the trees, and once a tree gets it, it has that disease for life.
So this disease is transmitted by leafhoppers, which are a small insect, and right now it is threatening the $250 billion industry here in Washington. By the minute the tree is infected, there's no way to cure it, and then you have to remove it. And currently the vectors are not being controlled very well, as they require broad-spectrum sprays frequently with very low thresholds.
This was a problem in the 1950s here in Washington. It's not anything new, but it's something that went away, largely due to a lot of efforts by a lot of people removing trees. And now it was a problem in California in the 1970s and 80s, and now it's come back here in Washington. And so we've developed a task force to try to work together with industry and government, because this is a real big problem. We've got to solve this quickly. There's a lot that's not known about these vectors, and as well as how they interact with the trees, the alternative hosts. So one of the problems with the phytoplasma that can cause little cherry disease is it can be found not just in cherry trees, it can be found in stone fruits, it can be found in weedy hosts around the orchard. And so to get the disease into the trees, the leafhoppers can pick it up either from tree to tree, move it around, or bring it in from outside the orchard. So one of the key things that we're trying to find out is how are the leafhoppers moving in the orchard, what causes them to feed on the trees, and what are the alternative hosts that they're using to bring that disease, the phytoplasma, into the orchard to damage the trees.
And currently in the world there are over 20,000 different kinds of leafhoppers, and right now we know of at least 6 that spread this disease. We're trying to find out if there are other vectors over the next few years, because with so many leafhoppers in the orchard, growers need to know, is this the one I need to care about or is it not? Because without the disease, the leafhopper doesn't cause much damage to the tree and isn't a concern on its own. So over the next couple of years, we're going to be looking at all the different leafhoppers that exist in orchards and testing them if they can acquire and transmit this disease, and at what rate and how quickly. As Tobin just picked up, there's a card here which shows one of our most dominant or prominent species in the orchard, which is Colydanus reductus. It has a black body with a yellow stripe on its pronotum or neck, and right now the last study that was done on it was in the 80s, and it only briefly mentioned it, so we don't really know much about this leafhopper other than it can vector the disease. We don't know how long its life cycle is, how quickly it vectors the disease, and these are all things we plan to find out over the next couple of years.
Yeah, this is one of the best tools that we have at controlling these leafhoppers, because if we don't know if it's there, we can't treat it, we don't know where it is. And so this is just a simple yellow sticky card that we can use to track the leafhoppers. The other things that we're trialing are methods of deterring the leafhoppers. We don't have to necessarily kill them, we just wanted to get them to go somewhere else and feed on other types of plants. And so Adrian is working on some different types of deterrents that we can use in the orchard.
So one of the things we're trying to do to lessen the need for growers to spray 10 to 16 times a year is come up with a season-long sustainable management for these leafhoppers. And one of the ways we're trying to do that is prevent them from feeding on the trees. Because if they don't feed on the trees, they can't pass the disease. And one of the cool techniques that is recently being applied to cherries is the use of kaolin clay, which is an organic clay that's harmless. It even was used as a food additive at one point. And what that does is it masks the tree in a white color, preventing the green from the leafhoppers to identify it. It also creates an abrasive, rough surface that they don't like to walk on. So for the next couple of years, we're testing to see if we basically paint these trees white with clay after harvest, so there's no needs for MRLs or any issues with harvesting and selling. Can this clay prevent the leafhoppers from landing on it and feeding on it, because they can't see it and they don't like to walk on it? Another one that we're trying is the use of Extende, which is a ground cover. So these leafhoppers love broadleaf weeds down on the ground cover, and if we can cover those up, we may prevent them from ever accessing a host that they may need to survive. So if you can cover the ground weeds, preventing them from ever feeding and picking up the disease or being able to survive and live in the orchard, or if you can mask the trees and camouflage them from the leafhoppers, preventing them from ever passing the disease. And these would both be season-long techniques that do not cause, they're organics, they can be used in both conventional and organic methods. And they won't cause any, hopefully, disruptive effects down the line. But we'll be testing this for the next couple of years, and hopefully by 2023 we'll have some answers.
we don't have really good estimates for how widespread this is, because this is all happening so quickly. And initially growers didn't like to talk about it because they were afraid that they'd have a stigma of having the disease in their orchard. But at this point, there's been enough media on it that everybody knows, everybody's got this, and everyone's struggling with this. And so it's really kind of opened up the doors of communication. We know that there are at least a couple 100,000 trees that have been removed, but at this point, not that many surveys, people have responded to the surveys estimating how many trees have been removed, and so that's probably an extreme underestimate. Just to give an idea of the impact of this, one of the growers was telling me they were really interested in finding out how widespread this is, so they were going to look at the satellite images just to see how many orchards had been removed. So that's a level of impact we're dealing with. It's not that you have to walk around an orchard to find out how many trees are being affected by this. You can actually tell by satellite images. What tends to happen is you'll get about 5% incidence in an orchard, and then it'll double the next year to about 10%, and then about 20%. At that point, people are removing the whole orchard because they know that the next year is going to be 40%, and it's just not economically viable. And then once the orchard is removed, you can't just go in and replant, because those suckers will reemerge and they'll reinfect the new trees that come up. And so you have to remove all the suckers, remove all of the phloem where the phytoplasma can survive in the soil, and then wait a couple years before you replant it again, at least. So one of the reasons why this is such a big economic impact on the cherry industry here, and as well as Oregon, and people are starting to find this emerging in California as well, is that once an orchard is removed, it's not just that you can immediately replant that. You have to wait a couple of years to make sure that the phytoplasma is not still living in the orchard, but you have to wait a couple more years to do that, and then it's going to take a few years for that orchard to start bearing fruit again. And so we're talking about a big economic impact of, say, seven years, and so that's all years where that grower is not producing cherries from that orchard. The other thing that's really important here is the amount of times that orchards are having to treat these blocks even after they harvest it. So do you want to talk about some of those impacts?
Yeah, definitely. So the leafhoppers peak after harvest, and that's usually when growers used to not need to care about pests anymore. But now that they have this pest that's transmitting disease after harvest, they're spraying usually bi-monthly, every other week in conventional blocks, while organics need to spray sometimes up to every week, all the way through October. So that is totaling between 8 to 16 more sprays than they used to have to do because of this disease. So that is definitely increasing the cost of management for these blocks, past the loss of the trees themselves. In the last few years, they've developed a clean plant center where they can send samples of trees that they think might be infected to see how many of these trees are actually with the disease. And what's astonishing is how quickly the rates of positive trees have increased. In the beginning, when scouts were looking for it, they would find 10 to 15% in their orchards of the samples they submitted, but recently, in the last couple of years, it's climbed to almost 40%, showing that this is really reaching an epidemic level, and it's not just a tree-by-tree basis, it's taking out whole blocks and acreage, which will not be used in production for years, and a lot of these growers can't sustain that 8-year loss of revenue. And so a lot of orchards are actually just getting sold and not replanted.
One of the things that really complicates removing trees is that the phytoplasma that causes little cherry disease can actually be spread underground through root grafting as well. And it's difficult to know which trees are actually connected to that tree that you remove. So one of the ways that we can evaluate that is if you cut down the tree and then you add glyphosate to the stump, you can actually see which trees surrounding it have picked up glyphosate symptoms, and that allows you to know those trees are already connected underground and may have actually gotten the phytoplasma as well. So then once you see those symptoms, you know you can remove those trees also. So it's not just the tree that shows the symptoms that ends up being removed, but also the trees surrounding it that are also connected through the root grafting. And that wasn't necessarily a problem in California because they didn't have as much root grafting back in the 80s. Now it's a bigger issue because there's more trees that are connected, and so that can magnify the problems that we experience here.
And one of the main issues that we have is that the symptoms don't usually appear for 2 to 3 years, so that gives a year or two for it to spread to the neighboring trees going completely unnoticed. So you can lose a whole quarter of a block over just a couple of years without even knowing.